Hello once again, it's Mr. Pete. Welcome back to the shop, and today I'm embarking on a new project, and this will be a multi-part video. I'm not sure how many, but the video will be on the building of a 2 by 48 inch belt sander, band sander, and it'll be based pretty much on the design of the Kalamazoo. I have two of these. Also, there's some similarities between what I'm going to do and the Dayton sander, and there's a recent video on me repairing this, so check that out as well. Now, both of these sanders use an electric motor, and one of the wheels is mounted on the motor, so it's possible you could use a motor and belt drive it, but you'd have to have a shaft. So I think this is the easiest way. It eliminates parts, but you do have to come up with your own motor if you're to build one of this design. And I'm also going to make the wheels, and that'll be the subject mainly of this video, as well as just an introduction to what I'm doing. Both of these sanders can be used in the horizontal position like this, as well as the vertical position. I far prefer the vertical position, but of course that's up to you and the job that you're performing at that time. Now let me break this down just a little bit into what the two different sanders look like here, and the way they built the wheels, and the way I'm going to make my wheels. My preference here is for the Kalamazoo, based on a Baldur motor. Now, the Dayton is a much cheaper model. I don't know if they still make this or not, but notice that it uses an open frame motor that allows the grit to get in there, and that was the subject of the previous video, because this motor was all gunked up and needed repair. It uses the 2 by 48 belt. It does not have a switch, whereas this one has a built-in switch, so you just see that this is not as deluxe a model as the Kalamazoo. Now, the Kalamazoo is not a cheap sander. I think it's probably $250 or $300. The Dayton is based on stamped sheet metal wheels. A rather large one on the bottom, about a 6-incher, and then a smaller one on the top, and pretty much composed of stampings. These wheels cannot really be balanced very well because they're just a stamping rather than machined, and it does vibrate. It is a useful sander, but it has its limitations. I much prefer, as I said, the Kalamazoo. Now, the Kalamazoo uses, in this case, kind of a rubberized wheel on the bottom, and they use two different size wheels. Well, of course, they do over here too. So this is about a 4-inch, and I think this is a 3.5. I don't know why they use different diameters. Notice that the top one has 2 ball bearings, and the bottom one, of course, is mounted directly on the motor shaft. They both use a rather similar tool rest. This one is completely guarded. I believe this is an older model because they didn't even provide the top guard, but that would be easy enough to make. Tracking of the belt is always a problem on any sander, and since this is all inaccurate stampings, they have decided to track the belt by just a mechanism here where you're moving screws in and out and bringing things into alignment. They use a different system on the Kalamazoo, and that is the system that I'm going to use, and I'll just talk more about this down in the basement, because I'll cover that really when I'll make the parts. But the tracking system is totally different, and it is done by tilting the wheel really from left to right, the top wheel only. This Baldur motor, of course, is totally enclosed and fan cooled. It's 3450, and it's really a great motor. It can be mounted in this manner, or I think they call this an F-frame. I'm going to design and build mine off of the flange mounts here rather than a separate unit. As you can see, this framework here is not even touching the motor, whereas I'm going to mount it directly onto the motor. This motor is 1750 RPM, and they're getting a little bit higher speed here by using a large wheel. And I don't know offhand what the feet per minute is, but it would be easy enough to calculate. But quite dissimilarly, this one is a 3450 RPM with about a, what did I say, 4.5 or 5-inch wheel here. So I believe it runs at a higher speed. And you can base your design on whatever motor is available, either a 1750 or 3450, and that's what I'm doing. I'm using a motor that I had here in the shop. I'm not buying one. Note that this upper wheel on the Kalamazoo is plastic. There is no tire on it. It has 2 bearings in it, but the other one that I have down in the basement has an aluminum cast wheel, and it has been machined. This one required no machining, so it would have been cheaper to make. Mine will both have cast aluminum wheels, top and bottom. As I said, my design will be flange mounted type of motor, but if you use a regular motor like this, and try to find a capacitor start as well, but using 2 plates of steel, and probably a little bit bigger than this, you can mount the motor on this, like that, and then the other piece here will be welded and cut this to size, whatever is necessary, and a rather large hole right here through which the shaft and even this part of the casting can protrude, and then the wheel mounted directly on there, and then this plate will serve as a basis to mount your vertical members. So that's how I would go about it if you're going to use this type of motor, which is probably much more common. 1.5 horsepower is really too powerful. I'm just showing you that because that is the kind of motor that I have available right here on the bench. Now what I'm going to do is go down into the basement and start talking about what I have done so far, and I've already built a prototype, so I will show you that and then start talking about the wheels. And since I'm casting them in my own home foundry from 3D printed patterns, it may be different than the way you're going to do it, because you probably do not have a home foundry, but you could machine the wheels from solid stock, or you could even probably buy wheels, but then you're getting into too great expense, and probably not that many people are going to build this. This is really an entertaining type of video on how I am doing it, because in fact I don't even need one of these sanders. I already have 3 of them. I'm in the basement shop, obviously, and here is the prototype, and I've been working on this on and off for several weeks, so I've jumped ahead here, I realize, but I wanted to show you what my finished version of this looks like. And of course you could certainly modify this. Matter of fact, I'll probably modify it a little bit as I do the build, because I'm essentially going to rebuild this for you in this video. But notice that I have a aluminum wheel, and it's been so long since I did this, I have to remeasure the wheels. I forgot what they were. So this bottom one is 5-inch, more or less. The top one is 4-inch. Now why Kalamazoo made 2 different size wheels, I don't know, because I did try to get this surface here vertical, which means that the post here has to be a little bit off center. This wheel, again, mounted directly to the motor shaft, and it's keyed, and there's a set screw that you can't see, and then I even put a bolt into a drilled and tapped hole, so this wheel absolutely cannot move. The upper shaft is 1/2 inch diameter. There are 2 ball bearings in this wheel, and we got a platen here, a tool rest. Again, it's mounted on a Baldur 3450 motor. I do intend to put a switch here. Really, a switch is absolutely essential. I had one in stock, so at some point I'll mount that switch. I think there'll be room in here so that it will be similar to this Baldur motor over here. The entire unit probably should be bolted to a board or some other type of base, and I'll show you what I have in mind later on. But this is the plate here, and it's about 3/16 thick. that is mounted directly by 4 bolts into the flange of the motor. And then the platen bolted onto that and the vertical posts. There's a spring in here that provides the tension, and the tracking is achieved here by loosening this bolt, and this can rotate probably about 10 degrees in either direction. I'll probably put a spacer in here. This of course will be cut off, and I'll think about the guards and all of that, safety guards, later on. I haven't gotten that far, but it is a good running machine, so I think I'll take it for a little test ride here, and then I'll get actually started with the project. I know I've been blabbing a lot, but this is the introduction to this this video and this project. You can skip through things that are too boring by running your video at 1.5 or 2 times the regular speed. Alright, you can see it hums right along. A little vibration, but not too bad. It's not walking around, but it should be mounted down. Seems to work pretty well. Make sure you wear glasses when you use something like this. I may be repeating myself sometimes because some of the footage was shot a long time ago, so I occasionally forget what I have said. But here are the 3D printed patterns, and these were done for me again by Kevin Peterson. It's a split pattern. This is the large wheel. It's a smaller hub because again that is drilled and mounted directly onto the motor, which is a 5/8 shaft. So that'll be keyed as well, reamed and keyed. This is the upper wheel, and I did change the design originally with a hole that was not cored. There's just a lot more to drill and bore, and then I added the core prints here, and that's mentioned in the other clip here, and that gives me a cored hole that is less likely to shrink and less material to remove, less machining. And originally I bought bearings that would be for a 5/8 shaft that would have mounted like that, but I have changed my mind, and those are 1/2" bore, and these are real cheap. I think that they were about, they were $6.99 including shipping. Alright, now I'm going to another few clips here that were done several weeks ago, and that is regarding actually molding these, casting them, and producing these, which of course here are already done. And then in the following video I will do the machining of the 2 wheels, because of course these wheels have to be crowned. I've done that in other videos, but that means that they're tapered in both directions, and that is what allows a belt to track and not to come off of a wheel. So let's go to that other video material now and see what I did here out in the foundry. And I'm not going to dwell on that because the video is already too long. Anyway, I'm not sure this video is necessary. It's another casting video, but and this will all be tied together here eventually as I work through a project. I might be getting ahead of myself, but I'm casting up these wheels. And you know, Kevin Peterson made these patterns for me, and I've already got, what, 5 of these wheels. And there's 2 different versions here. Now, there's one here with a smaller hub, and by the way, these will all be used as I make a belt sander like this, a 2x48, and the upper bearing here has, or the upper wheel has 2 bearings. The lower one is mounted directly on the motor shaft. So regarding these castings, this larger wheel with the smaller hub will mount on the motor shaft, as I just said. These are rough castings, not turned down yet. They're almost hot. I just made them. And I'm making a couple more, but I want to talk a bit about the larger one here. And that turned out fine. Matter of fact, I got 3 of them here that are just fine. But no foundry would make these this way for 2 reasons. First of all, it's so thick here that shrinkage could be a big problem. It isn't a problem with me because of the way I put the riser in it. But now, in order to drill and bore a relatively large hole in there that will accommodate bearings this size, that's a lot of material to remove. So I decided to attempt to cast another one with a core in it. So I'm going about it in an unorthodox manner. So let me talk about that and see what you think. And if this is a failure, of course, you never will see this video. So this is what the 3D printed pattern looked like originally. There was a center hole here. I have since drilled it 1/4 inch, and since I'm going to use a core, I need a core print. So I real quickly turned 2 of these, well, they're about 1 inch in diameter here at the small end. You can see it's tapered. I already have the other one in place here, but I think most of you are familiar with what a core print is. A core print is simply a projection or an addition to a pattern that will allow you or allow me to set a core in place. Now this is going to be a vertical core, and naturally I don't want to make a core box and all the work associated with that for really 1 or 2 castings. So how am I going to go about doing this? And that's why I say it might be a failure. So I put a double core print on there, and what I'm going to use for a core is simply this 1 inch aluminum tubing, thin walled, and I cut off a piece, I guess it was 2 3/8, and I have it packed with sand, with foundry sand. See that? Now, it would be nice if I could preheat this, because this is chilled and it will cause the metal to chill, but the whole idea here is that probably the molten metal will not melt this. More than likely it won't. Even if it did, it probably won't matter as long as the sand is held in place, and then ultimately the sand knocked out of the casting, and then it is ready to drill and bore, or whatever the operation is. That gives me a hole in there, of course, that is 1 inch in diameter, even though I need about 1 3/8, but it also reduces the need for a riser here in the middle, at least in my experience. So there will be no shrinkage here. See, if a riser wasn't used here in the middle, more than likely there would be a big sinkhole. So that's the purpose of that riser, and then it was gated here off to the side. I showed some pictures of that on Instagram, but I don't think I have any castings to show you now. So, alright, with all of that being said, let's go on out to the molding bench and I'll show you how I got that set up. I already made the mold and I am ready to cast it. See you in a minute. Here I am at the molding bench, and I already had closed the mold, and this is in fact ready to pour. And that's when I decided, well, I might as well go ahead and show this before I pour it, and then again after I pour the metal, then I'll show it to you when I open it to see if it's successful. So let me open this for you. The core is already set. There's a couple other castings in here too for one of my little vices, but you can see that the core is set in place. It's a vertical core, and yes, it's going to rattle around in there a little bit because it's not tapered. It's not truly the size and dimensions of the core print, because if it was a sand core made in a core box, it would be tapered and that would hold it in position a little bit better. But I don't think it's going to be a problem because it's going to be bored out much larger. But this is what it looks like now. So I'm going to go ahead and close the mold and fire up the furnace, and I'll talk to you again in about 60 minutes. All right, it's been about an hour. Let's see what we got here. At this point, it looks okay. Let me poke the sand out of here. Let me cool it off and take it down on the bench, and we'll see what it looks like. I think it's good. What I've been doing is making up a lot of castings, because once winter comes I can't make any castings till April. Alright, enough on that, and a little jaw, so I have extra jaws in the various sizes. Well, this was, if I dare say so myself, a resounding success. Just with a singular sprue and no riser. I know that some of the old-timers that are far more talented along this line than me are cringing at some of my techniques, but it works for me. Now, others have asked, why don't I vent it with a little wire? I have never had a problem with venting. Remember, the sand is very porous and permeable is, I guess, the word they like to use. So a lot of the gases can escape. Now, with cast iron, probably not, and with water-based sand, probably not, because steam forms and has to escape, but not so with the Petromon sand. So this is what I have compared to this. Reduces the weight. Boy, these are heavy castings. I do not know what I was thinking or why I specified different wall thicknesses to Kevin when he made this, but this is one heck of a heavy casting even compared to this. I didn't weigh them yet, but I guess it doesn't matter. I'm just pointing that out. Now, how will I remove this? Well, I will saw it off flush just with a hand hacksaw on both sides, and then just bore that out as I proceed to bore it for the bearings. And I'm going to use, these are 5/8 bore bearings. I ordered 1/2 inch. That reduces the outside diameter a little bit as well, so that's probably, or that is the route I'm going to go. Those are in the mail. And yes, I could have had Kevin produce this and 3D print it, but I did not think of it. I just didn't think of it. So that's why I ended up making these out of a wood dowel, and it only took me about 15 minutes to do the both of them with the taper and everything, so it was no big deal. However, that makes this thick enough to where I almost had to use a thicker foundry flask instead of a 3-inch, but a 3-inch did work, but this got awfully close to the top. Well, I cut those off, so I can't show you that. But let's say that a company was going to make thousands of these, 100,000. How much easier would it be to use a core and bore that out than to start from scratch like this and have to drill that out by the thousands? And also it uses less metal, and as I pointed out, shrinkage is the big factor as far as I'm concerned. I'm just trying to show you different ways of doing things, and that about concludes this. I've beat the subject to death and talked too much, and you will see this later in the winter as I go ahead and try to make this this belt sander, unless it's a failure. And then, of course, after I make my prototype, if it's a failure, I bury my mistakes. You'll never see them. That's why some people think I'm a good machinist, because I don't make any mistakes. Well, I make mistakes, I don't show them. All right, I hope you liked that out in the foundry. So that concludes this first part of the video. I've got plenty of wheels cast up, and as you can see, there were 2 more that are already machined. So in the following video, as I said, I will drill, bore, well, let's see, put a keyway in, just all the different operations to make these into finished wheels that are ready to go onto the motor. This is Tubalcain saying so long for now, and I'll see you in the next part of this video series.